Hey guys, welcome back to the last video for the week. Gonna have plenty for you guys to practice, so don't worry. So on our last video, if you'll remember, we worked on doing sums and differences, which is adding and subtracting. Well, we're gonna take it a bit further, and this time we're gonna talk about products. Which when we talk about products, we're talking about multiplication. That's right, my friends, multiplication. So for the majority of this, I think it's super simplistic, but I did work everything out that way there wouldn't be any confusion because as always, the book leaves some to be desired. So if you'll look right here, we have your radical 6 to the 8th, which you can combine and get. But, see, here's the thing. Factoring hasn't left yet. So your good friend Cody here went ahead and factored everything out for you so you could see. So I had 6 and 8, and I went ahead and factored, factored's not even a word, factored 6, 2 and 3, factored 8, 2, 3, 3. Why did I do this? Well, because I want to be able to bring these out, if you will. So now I have 2 to the first and 2 to the third. All right? So I can actually combine 2 and 2. So 2 and 2. The 2 to the third came from 8. The 2 to the first came from my 6. All right. That gave me 2 to the fourth. Bring down the remaining 3. So now I did that in order because now I can perfect square it. All right. So I can take perfect square of what? 4. Which, I mean, realistically, I think that's going to be 64 if you did this. No. I think this is 16. I don't know why I said that. All right, so I'm going to take the square, bring it out, so you can actually have a perfect square of 2 to the fourth. 3 doesn't, so you bring out 2 to the second power, which is 4, times square root of 3. Again. Because the book kind of does something like that, I think, but theirs is a little different. Well, theirs looks, yeah, it's about the same. On that one. All right, let's look at example 2. Example 2, we have negatives. So what did I talk about last time if we have negatives in here? We all understood we have negative ones, which translate as having a what? An I. Yeah, that's what I thought. We have an I. You guys remember what I squared is? I squared is -1. So let's just kind of go back and visit this. Here we had 2 to the index of 4x squared. So our index number is 3 on both sides. I still want to break these down. And one thing you can actually do, you can go do some combination. You can go ahead and combine these and get 10. So 2 times 5 gives you 10. You can put these in the same radical. Okay. Then what you're going to want to do is factor them out. So I have 2 squared x squared, because I factored this out. Then I have 2 to the fourth x to the first. All right. But here's my thing. Now I can actually do what? Can I add like terms? I can, but I want to make sure that I'm adding things that are already broken down. Since this is 3, all right, that's what I want. That's what I want to be looking for. Ways I can make this 3. That way I can get rid of them, if you will. So here I have to bring down, I need this to be 3, so how can I do that? Well, I can do 2 to the second and 2 to the third, which gives me 2 to the sixth. All right. I can bring down 2 to the fourth. And again, how did I get 3? I broke this down into x to the first. So it'll be 2 to the third, x to the first, because I want to be able to have it in a radical of 3. Why do I want it in a radical of 3? Because my index number is what? 3. Previously up here we had the understood 2. Here we have 3. So we're factoring things that we can make this 3. All right. I haven't done anything special, but just factor from here to here and from here to here. And if you can look in your book right here on B, they've done the exact same thing. They went ahead and combined 5 and 2, got 10. they combined these 4x and 16. They gave them 2x, x2, 2 to the fourth, because that's just 2 times 2 times 2 times 2, x. All right. They went ahead and combined terms that they could. So 2 went to 2 here, which gave you 2x to the, 2 to the 6. X and x gave you x to the third. All right. Since it was x to the third, it can come out of the radical because that's what we needed. But here's the step they didn't show you. They factored out this 6, and they got 2 to the second and 2 to the third, which I put that there so you could see. They didn't show how they got that, so they factored this out. So when you multiply 2 and 3, it gives you 6 right here. Again, they left that out. So with that being said, this can now disappear from inside the radical, and it's going to come out. So we're going to bring out our 2 to the second, which is this, x to the first. And when we bring those out, I went over here and worked it out, it's going to be 10 times 2x, 2 to the second, x. And when you multiply that, it's really going to be 4. So I don't even think I wrote down the answer. But anyway, let me go ahead and write that down. So when I multiply 10 times 4x, that gives me 40x. Back it out a little bit so you guys can see. All right, let's move on to example 2. Example 2. It's I guess just did B part. I apologize. I might say I did example 2. Example 2 is going to be -6 times square root of -21. Since we don't have like anything outside the radical, it's not going to be, we don't have an index, so the index is understood to be 2. So if you'll see, they brought down, they have 6 and 21. As we've been doing before, we're factoring them. We can combine them, and I've done that right here on mine that I worked out. You want to bring out I, which is going to be negative and negative. I squared will actually come out here because it'd be negative 1. So we have 6 times 21. I went ahead and factored 6. Why did I do that? I wanted to get a 3 squared. That way I can take the square root of it. What about 21? Because really what we're factoring is here. I went ahead and factored 126, because that's what you get when you multiply 6 times 21. So when we factor that down, factoring of 126, we get 3 squared times 7. This was squared, so we brought it out. I squared becomes -1. So since I brought out 3, it's 3 times -1, which is -3. 2 times 7, which is 14. So again, factor out 126. You get 2 times 3 squared times 7. You brought out your -1s. -1 and -1 inside the radical is I squared. So I squared is -1. Bring that out. You're left with 2 and 7 on the inside. And your perfect square, which was 3 squared, came out. So it's 3. 3 times -1, -3. 2 times 7, 14. And like I said, I'll post all these online, all the workout sheets. That way you guys can see them step by step. All right, example 3. I'll let you guys look at theirs, what we're given. So basically what I did here is I factored everything out. We're trying to find terms that we can combine. I think we were given, let's see if there's anything that we could add together at the beginning. Okay, yeah, we'll look at theirs and I'll bring mine in. All right, so we had 2 times the square root of 3 times, sorry for the, there it is, 1 plus 3 times square root of 6 minus 6 times square root of 3. All right, if you're just looking at this as is there any like terms that you can combine together? Well, one thing that they've done here that I think is kind of might have confused at first is you needed to be able to bring your 2 to the third. If you'll see, they've put 6, they broke down right here. All right, this 6. So that gave us 3 times 2 times 3. So we had like terms here, if you will, because you can multiply this 2 and 3, okay? 2 and 3, and that's where we get a 6 at right here. And if you multiply the 2 and 6, I got 12. So that's where everything came from. The 2, because this is distribution, so don't forget that. So 2 times 3, 6, 2 times 6, 12. All right? And so when doing so, they factored out, because since these were both, you had 6 right here, you factored out 3, 2, and 3. And this is your 12 from distribution. And 3 to the first, 3 to the first is what? 3 to the second. We brought down our 2 to the third, plus when you multiply your 3, because, make sure, yeah. Bring mine in now. You can see. All right. So since this was going to be our 3 to the 6th, we multiplied, brought down 2. This is going to be multiplied by 3, which is going to give us 18. And when I say it's multiplied by 3, it's all in what you bring out. All right. If you take one of your perfect squares out, because 3 and 3 is going to be 9, which 9 will be a perfect square. You bring it out, it's going to be 3. Okay. So, and what I say is, if you multiply 3, it's 9. 9 is a perfect square. So that would be 3. 3 times 6 is 18, leaving you with this 2. All right, so that's where we get 18. Same thing here. 9 is a perfect square. Bring it out. 3 times 12, negative 36. This doesn't have a perfect square, so it stays as is. So again, just so you're not confused how I got this 18 from here. Factored out from the beginning, you know, did my distribution. But here, 3 times 3, 9. Okay? 9's a perfect square. Bring it out. 3 times 6 is 18. Leave me with just this 2. These 3's are gone. 9's a perfect square. Square it. It's 3. 3 times 12, negative 36. And that's our answer. I didn't work out example 4 because I think you guys can do example 4 because it's just the FOIL method. And we did that countless times. One thing definitely do not forget, I squared. I squared equals what? I squared equals negative 1. All right, let's look at example 5 here. It's really, really simplistic also. So you got 2 to the 7th times 32x. All right. What you're going to want to do here is you're going to factor. I went ahead and did 32. I factored it. It's 2 to the 5th. That means you do 2 times 2 times 2 5 times, and that gives you what? That gives you 32x. I did that way I can do a combination at the end here. Because I wanted these numbers right here, which is our bases, our base 2. Because this already had a 2, I wanted to make this a 2, and now I did so. Even though it's got 5x, when I multiply these together, my bases are both now 2's. So factor 32, I already had a base of 7, so our base stays the same. Now I just combine my exponents, 5x plus 7. All right? Super, super easy. Factor to get my base. This already had base 2. It's base 2 to the square root of 7. I mean, not square root, base to the exponential factor of 7. So it's got 2 to the 7th power from here. Broke this down. you can't really factor x, but so 2 to the 5th power, so it's 2, 5x. Our base is 2, 5x plus 7. All right, my friends, we're going on our last example. It's pretty simple also. You got the square root of 3 with, oh, but here's the kicker. We got an index of 3 to the 9th power. And from last time, I don't know if you guys remember our bases. We did this, I think, in 7.2. Might have been 7.1. Same concept here, but guess what? Work them out so we can do step by step. This one's going to be 3. Since you don't know, this doesn't have an index. It's an understood index of what? 2. It's a base 2. This one's going to be a base 3. Understood because it's not, since it's not there, you just already automatically assume. We bring the 3 down with our base. So it's 3 and their exponent is 1 over 2. Here, we're going to bring down 3 and that's not 32. That's exponent 2. Sorry, it might look like 32. But it's 3 to the power of 2. So 3, base 3, exponent 2 over 3. So exponent was 1 here, exponent is 2 here. Base is 3 here, base is 2 here. Now before I can do anything with them, I need to have common denominators. So how do I get that? Well, I'll multiply this one by 3 and multiply this one by 2. So this one gives me 3 over 6. This one gives me 4 over 6. So, and when I add these, now here's the thing. They have the same base, okay? They have the same base number now. So I can add 3, 6 plus 4, 6, which gives me 3 and 7, 6. I don't mind if you leave it there, but I would prefer you taking it to the next level. So you got, this is not 37. I know it looks like it, but I'm writing it almost like it was at the beginning here because now I'm trying to orchestrate it where it looks with my exponent, because I want it to be a radical rational exponent with it, because we got the same base now, but I want to make it a radical rational exponent. So I take my 3, which now becomes my root that goes inside my radical. This is my exponent, which is attached to 3. And this is my new index. So I have 6, 3 to the 7th power. And if I want to, I can break that down. And when I say break it down, I mean get rid of some of it. You can leave it here, or you can factor it further even one more time. I broke the 7th power down to 6 to the 1st, 3 to the 1st. Only reason I did that is because our index number is 6, so that just makes our number smaller. We have 3, and keep our index 6. This is now gone, but we keep 3 to the 1st. And guys, that'll take care of 7.4. As always, if you have any questions, please feel free to message me. You have my number, so text me. We can do Facebook Live. We can do, did I say Facebook? Yeah, we can do Facebook Live. You guys do a FaceTime call. So just make sure that we stay in touch and that you guys are getting this. Just hang in there. We've almost got this year whipped, friends. And I shall talk to you guys later.